Okay, we're going to look more how to graph polynomial functions, and we're going to look at the behavior at the zeros. As these functions cross the x-axis at the zeros, what are they doing? And we're going to look at functions in factored form, so not in standard form. Notice how we have them written as their factors. So here's going to be the first example we look at. Now, I want to first pull in what we've learned in previous videos, and that's about the end behavior. So if I look at the degree of this polynomial, it's 1, 2, 3, 4, 5, 6, because this would be a 1 exponent. So this is a 6th degree polynomial. And it looks like if we were to distribute this out, since all these are positive, like our x, our dominating term would be a positive x, but then you got this negative. So it's got that because of this negative, it would have a negative leading coefficient. Meaning the end behavior, since it's even degree, it's going to be the same end behavior. It's going to match on the left as it does on the right. And that negative leading coefficient means it's going to go down. So we have a function that's going to look like this on the ends. Now, that's prior knowledge. Let's look at what we're doing with the zeros. So, at a first degree zero, first off, the zero, actually I'm going to have to copy this down below so I can write all over it. Okay, now I'm ready. So forgive me for this rough little table down here, but I basically have 3 different zeros. I've got one here, and one here. Each factor is going to give me a 0. And so, first off, the 0 is what makes the factor equal 0. In other words, what plus 2 equals 0. And for this first one, the actual 0 would be -2. That means our graph is going to cross the x-axis at -2. Something's going to happen there. And then we have, right here, if x plus 1 squared is one of our zeros, then it looks like our 0 would be -1. So I'm going to put the -1 there. And then lastly, we have x minus 1 cubed. So that would be a positive 1 because 1 minus 1 is 0. So then we've got another 0 here. So these are the 3 places that our graph is going to intersect the x-axis. Now, what happens there, and before I get too far into it, we know from kind of what we examined with the end behavior that we're going to have this and we're going to have this. Okay? Now, the question is, what happens in between? Now, let's look at this. This is a first degree 0. If your 0 is first degree or has a multiplicity of 1, then what it's going to do is it's just going to pass through at that 0. Meaning our function is going to come up and it's just going to pass through that 0 of -2. Then we have our second 0, the -1, this one right here. That 0 is squared. It's a multiplicity of 2. That means it's not going to pass through, but it's going to have what I call a bounce. Meaning our graph is going to come back down and it is going to touch at that -1, but it's going to bounce there and come back up. Okay? Oops. And then let's look at this last 0. This is a third degree 0. And what that's going to do is it's going to do what I call a wobble. And let me show you what I mean by a wobble. That means it's going to come down and then kind of whoop. I don't know if I drew that well enough for you to see it. Let me draw it a little bit better. It means our function, if here's our 0, it's going to go whoop. See how it kind of bends and comes back down? I call that a wobble. But this is just a rough sketch. All we're doing with these is getting a rough sketch of what the graph looks like. Reminder, I know from previous videos that it's going to go down on both sides, but here, knowing the multiplicity, knowing the exponent on your zeros tells you what exactly is happening at those zeros. But let's do another example. Okay. Okay, in this 0, we have a 0 of 0 itself. We have a 0 of -5. And we have a 0 of -1. So as I kind of plot those on my graph, we've got 0, we've got -1, and then we've got -2, 3, 4, 5. Okay? Now, let's look at what our end behavior would be. Okay? Because I like to kind of figure out the end behavior first. Looks like our degree is going to be 1, 2, 3, 4, 5, 6. So we have a 6th degree. And then let's figure out what the leading coefficient would be. Since this is positive, and this x is positive, and this x is positive, whenever I multiplied everything out, what we'd have is we'd have a positive leading coefficient. So what that means is if it's 6th degree, that means our end behavior is going to match. It's either going to do that or it's going to do that. But since we have the positive leading coefficient, what we know is it's going to be this one. Our function is going to increase as it moves to the left, and it's going to increase as it moves to the right. So coming off of this 0 over here, this -5, our function is going to go up, and coming off of this 0 over here, our function is going to go up. So I kind of like to figure out that first, and then we can figure out, okay, what's happening in here in the intermediate. So if I look at our 0 of 0 right here, it's squared. That means it has a multiplicity of 2. What happens when your 0 is squared is your function is going to bounce. So notice we're going to come down, we're going to touch at 0, and we're going to turn back up. Now let's look at the 0 of -1. When I look at the 0 of -1, it has an exponent of 3, or in other words, it has a multiplicity of 3. If you remember from the previous slide, that means we're going to have a wobble at -1. That means our graph is going to turn, and it's going to come back to pass through, but instead of just going straight through, it's going to wobble a little bit before it comes down, okay? And then lastly, let's look at the -5. The -5 up here doesn't have an exponent, but there's always an assumed 1. And so if it has just a first power, that means our function is going to do nothing other than pass through. So here's just, once again, a rough sketch of what that graph would look like.